Oh, oh, hi. Oh, I have popped up here. Great. I think I found out what was wrong with the streaming. There was just an old one that was caught in the queue. But basically, I actually some crazy new stuff came to me just suddenly, and so I was trying to get to bed, and I just thought I should note it down really, because it's all about isothermal geodesics. Because as soon as it's one of those things when I was reading through the wiki about how, and I'd never actually looked into the proof the um, of the Berling's proof of the existence of, in this case, the analytic um, uh, quasi-conformal map, then that's going to be nice too, because that really makes things really beautiful. Um, but so I was going to make some comments about that, and this is really just a little teaser into what I'll probably just run the full talk, but I've given for anyone who is interested. The notes cover pretty well what I want to be discussing. I think it doesn't seem to be a long one. It was just a little slightly different picture of the nucleon, and yeah, there might well be weird string modes going on in there, but when I got Dali to do its rendition of it for me, and I'm sure it didn't know quite. Well, no, actually, it's quite. What Dali did was quite interesting because it seemed to have, it didn't choose regular patterns for the lattice, and I thought, oh, there's some interesting degrees of freedom that you can store a lot of information in that. So it's not like you just have to. There are lots of ways that you might be able to tessellate stuff, and particularly because we've all got all these high dimensional crosslinks, they can vibrate in all kinds of way between the two. This is the thing that when you're setting up a lattice theory, regardless of what it is, if you want it to be chiral, you have to be linking it to its superpartner. You just can't get away with that. That's like a no-go theorem. Anyway, so I think that's about it for the moment, and I'm just going to wrap up and try and get some sleep now, and pray that I don't get thrown into the Planck level, because I'm really not really ready for it yet. I'm feeling pretty tired as it is, and being thrown into the nucleon was kind of, I'm quite grateful for coming back here, but I've got to kind of center myself a bit and get on with doing things that are not this for a few moments, because it's really taking a lot of me out of me, kind of traveling through event horizons and seeing what's in there and pulling it back. So I've got to kind of spend a bit of time on myself. But I hope so far you've enjoyed all this stuff. I certainly have really found it amazing, and as I think you're aware, I don't mind making mistakes. I correct my own mistakes, and if anyone's got any interesting ideas on how to tackle any of these really tricky problems. I think I didn't make this stuff very clear about the Godelization, and how you're basically trying to count this n for a g, and then you just kind of ask it, are you a fermion or are you a boson, or how long do you live for, and if you live for 5 then you say you live for 10, and then if it's 10 it's 5, and you've confused the system, and then you can kind of make it eternal, because as I said, I think I mentioned it, this is just creation of virtual particles, so we want to create something real, and this is the way via Godelization. So it's funny how things kind of fall insides and outsides in peculiar ways, but hey, that's the way of a theory that falls backwards and forwards in time, because that's what it's about. So let's embrace it and try and tune into those vibrations that seem to be, sending information left, right, and center. So I'm really enjoying all of this, and I hope you are. I kind of feel a bit silly for deleting the videos that I made some really, really stupid mistakes in, because those stupid mistakes were the mistakes that actually led to these things happening. So it's one of those things where I hope you don't mind. I probably won't be deleting anything, even if I make a mistake, because I do normally find those mistakes are the things that actually can lead to breakthroughs. So it's that thing between consistency and inconsistency. There's a thunk line between that too, and that's what you're playing with the whole time when you're trying to you try and build up a theory and then knock it down, because as mentioned, we've got very tight constraints here. We've got a vector field theory that is just like saying thou shalt not, and we've got Luke quantum gravity saying thou shalt not. So we've got a whole load of things giving us no-go theorems, and these are the things that we're basically using to pin the stuff down. And so what basically the experts will be able to tell is that just from the title that we've tracked down the Noether invariant, which is the isothermal geodesics. So once you've got that, it's kind of like it's a spectral effect, and so it's a really clever effect where it's using the heat of the processing to actually redirect the light beams, and then very cleverly using the kind of anti-heat to you can't really, you have to use it. It's a very, very careful, you have to really carefully prepare your states, as Aronoff has been kind of, this was where it all started. This is where a lot of this recent stuff started, So it's all about pre and post selection. Oh, and there was one thing that I didn't even write in the notes, and it's probably worth mentioning, which is there's another nice Penrose test, which is we can do checks of the red and blue. Once we shifted out the CMBs, what we can do is actually compare the entropies of patches, and in that way we can actually check whether we are an isolated system or whether there is other stuff that is influencing us, because that's kind of quite, well, we know that there is stuff outside of what we can see, but this is kind of saying that there's not that much more. Because yes, there's other event horizons, etc., and we know they're not the same. So we know that we're not like in a completely short period or anything like that. It's a long period. But by looking at the CMBs and correlations between it, there might be information that could be worked out about the correlations. But my guess is it's going to be the longest possible period with the smallest possible information to generate it. And that will be interesting. But then the other thing is is it an eternal universe, or are we just a virtual particle? We can't really tell that, but then again, the duality says that there's again some kind of eternal duality to that anyway. So I think, these shamanic principles kind of do help in a way to journey there and back. And I was counting this. I had some thoughts about this stuff here with the counting, because the U1, U2 could be U2 that could be a firewall too, because these are kind of quarky, and these are kind of like, I don't know. You see, but since things can shift in the bulk between personalities, it's like very difficult to, you've got to kind of, the way I'm trying to do it, I think is, but then the problem is, as you find, if you start thinking about these event horizons and really going there, you find that time starts speeding up as though you're actually traveling there. So beware of that. It's not somewhere where you really want to be hanging around that long, because it does seem to have genuine effects on the self, and that is part of the teachings, that when you go down there, you're kind of asking someone to be a Planck level microscope, and so there's enormous amount of energy being borrowed and lent to do that, and give and take, everything has to be give and take. And so I don't know really. I mean, maybe that's it. The experts have enough in the notes really to put everything together, and I think I've covered most of it. Um, so it was just really the notion that the picture, the journey into the nucleon, is really summing up. What I got Dali to do is to try and sum up the quarks, and I didn't tell it about the top quark, incidentally. I wanted to see whether it would recognize that the top quark was twice as massive, and basically it did. And what's more, it kind of realized there was stuff going on, and it realized each of them also had these kind of geodesic domes. And the other thing is it drew these beams of light and other particles of that. I didn't ask it to do that. And then when I put the two opposite each other, I suddenly noticed that they're making the light beams are making perfect clock signals between each other. And the other thing was that one of the cubes, with inverted colours, the colours are literally kind of inverting. Because when I did literally invert colours, suddenly the things started coming out reddish, which is exactly what we're kind of seeing in these weird telescope pictures. And I was thinking, maybe there's more to that RGB stuff than we were thinking, that there is actually some kind of strange phenomenon going on where the chemistry and everything within the supersector is very, very different. But if we're actually getting a picture of the supersector, then we're seeing a very different universe. We're seeing the momentum space of our own, we might be seeing the momentum space of our own position space. That's another way of seeing it. So I guess I've really actually covered most of what I wanted to say in this one, really. Oh no, there was one thing, the top mass. Twice the other masses. Well, what have we got? We've got bits. And so we got 4 bits. Then that means we've got an extra bit to go. And why is an extra bit? Why is the top mass? Why would a programmer want the top mass to be twice the mass? Why not do something else with that bit? I mean, it's a missing bit otherwise. And I was thinking, well, other than it probably works absolutely beautifully with GF27 in a way that one of you lot will be able to tell me. It's the absolutely perfect way of representing a trit. Because what we do is we have yes, no as the light ones. And the heavy one means maybe. Because that's got to do a lot more processing and there's a lot more communication. And it's known psychologically that indecision just is stressful. Too much choice is stressful too. Because people do find it difficult to balance all of those high order loop amplitudes. And at some time I really want to get talking about that, because in a way, I mean, the theory just becomes so beautiful, because it's just like Escher-like, because in a way things get easier because it's everything's on the hyperbolic plane once you go above 6. So and then you get all this amazing stuff with angled triangles and things like that. So, I mean, I really have got to brush up all my software tools for drawing all of this stuff, because that was what I used to do basically. So, and it's great fun, but it does require a lot of care and attention. And so yeah, I just noticed that the nucleon is the perfect trit, and with maybe having that extra. So what it's trying to basically do is solve a halting problem. We can see that. So we can kind of see that the code in there is already bewerken. So that's what we can imagine is going on at the Planck scale, actually. It's just basically churning through bewerken, trying to see whether a process halts or not, and it's kind of got, you know, maybes and yeses, and every time there's a maybe, it has to use a little more heat, and that it distorts the matter, so the time slows down, create, you know, more stuff, sinks down the potential well until finally it either just gives up and goes on to the next, you know, thing, or comes back with an answer that's useful. And by that I mean that there can be, you know, rabbit holes that don't end, they just branch off, and yes, it does go back, but heaven knows what can happen down at that level. I mean, particularly if there are other universes that can interact with us in other ways, you know, you just never know. You know, with the ones that we're looking at the moment are just basically quite tame algebraic ones. I'm sure there are other far wilder ones, but at the moment this one's enough for me. And is there anything else really that I'd seen? Oh yeah, I'm just looking at the picture. Everything is there in the picture. So what I've done is I asked it to put a load of muons in there too. Obviously, it kind of like a haze. I asked it to do a haze of muons. And the interesting thing that it did was it regarded gravity. And it was like, oh, look at that. Look at what gravity is doing. It's bringing things close together so that they can merge their information. And there's kind of two little bits and then the big bit sitting there kind of pondering, sending stuff down the Planck level to computing all the isothermals, and eventually flash. The information kind of gets tunneled back up and then out the event horizon through the, you know, no monopoles. Obviously some amazing stuff is going in there, but you know, how is it doing the Fourier transform? How is it doing all of the isothermals? And it's got BW in there too. So, you know, it's got the whole Godel mechanism in there. And that's a lot of code. And the code that Godel wrote was very sketchy, to say the least. It wouldn't compile. It didn't. I found a lot of errors in there. Nothing really major. Nothing that couldn't be fixed. They were all minor bugs, just in the kind of. Well, you can't really run it. So you need someone who's someone like me, who's a professional programmer rather than a mathematician, to read through it, because I tell you, it's like wasn't a pretty experience. Going through it line by line, because I really didn't understand what it was doing at first, and I had to take it to pieces bit by bit, go through his papers. Actually, like, and there's some bits that I think, no, that's a really bad way to do it. There's much neater ways, and of course nowadays there are much neater ways of doing it, but there are some even neater ways of doing it. But you know, as I say, I've got a few tricks up my sleeve. So you know, I was buried in denotational semantics for I don't know how long, and quantum functional programming, and for whatever, I must have been early, because as I said, I was doing this all in the early 90s, so it seems to have taken off since and left me completely behind. But yeah, never mind, it's just like one of those things, and I'm just happy to be here, kind of like being able to have some kind of communication with anyone who might be interested. So hey, I think this can kind of wrap it up. I really would like to kind of, if anyone else can take over, it would be nice to get rest. Anyway, it's great being here, and I hope you're all enjoying yourselves. And lots of love to everyone. All the best. Bye.